Okay, well, good morning, everybody. Welcome to Becknology Days today for Friday. My name is Brad Fruth. I'm the Director of Innovation here at Beck's Hybrids. We're going to kick off a great day of conversations here at Becknology Days, and very excited to have two guys with us here. We have a great tour today on tour number 11. So we encourage you, if you're interested in anything here, to jump on Tour 11. But joined by Andrew from Swarm Farm and Chad from Verdant. Guys, thank you very much for being with us. Why don't you guys just do a quick introduction and introduce us to a little bit about what you're doing here at Becknology Days?
So Andrew Bate, co-founder of Swarm Farm Robotics. I'm an Australian farmer. I farm in Queensland, Australia. And we founded Swarm Farm Robotics about 15 years ago. We've been working here with Beck's now for a couple of seasons with one of our autonomous robots. It's been a fantastic experience and just really enjoying learning more about US farming and corn and soybean production.
Morning, my name's Chad Yago. I'm the Director of Agronomy at Verdant Robotics. So I'm an Illinois corn and soybean farm kid, so happy to be here in the Midwest. I'm actually located in the Midwest, but our company, Verdant, is out there in Silicon Valley. Mainly the technology that we've been working on is highly precision application, and so we've been working with Beck's again for a couple years, like Swarm Farm. This year we're pretty excited to have our full production unit in the field, where we've been looking at organic soybean production and how we can use organically approved products in Midwestern row crops, because primarily the development and the sales that we've had so far have been into the vegetable crops, mainly on the West Coast. So we're really excited to be here in the Midwest with Beck's today.
Yeah, sounds great. Well, thank you very much again for being here, guys. Why don't you talk a little bit about maybe how your technology started, and how you guys got your start. Sometimes technology in row crop, it's not always developed for us. Sometimes we have to adapt that sort of technology, and we're not used to a lot of Australian farmers coming over and trying to sell us stuff. So why don't you talk a little bit, Andrew, about how you got started and kind of the evolution of the product here over the last couple of years?
Yeah, so I guess my background is as a farmer and an agronomist. I spent 25 years farming, mostly grain. So I grow wheat, sorghum, mung beans, barley, chickpeas, those sort of crops. And also run beef cattle as well. And Swarm Farm Robotics as an autonomy company was really born out of, I guess, our own farm's desire to be better farmers. And if you look at farming, it's been a path to success has been getting bigger machinery so you can farm more acres, put more acres under your belt, whether you lease them or buy them, and expand your business. And so we're all buying these bigger tractors, bigger combines, bigger sprayers, and we went and did that ourselves. And that was a catalyst for starting Swarm Farm, because we kind of supersized everything, got the biggest combines we could get, the biggest tractors, and as we got bigger and bigger and bigger, we kind of realized we weren't farming as well as we used to. The machines were too heavy, they were too expensive, but they compromised so much because they're so big, they were kind of cumbersome in the field. And the big wake-up call for us was, we're only doing this to farm more acres and save labour. We're not doing this to be better farmers. And so with robotics, the idea was, well, if we can go robotic, we can make machines small, simple, lower cost, lighter weight, and then start loading it with advanced technology with robotics. And kind of that's sort of why we started the company. So it was never about we could automate something. It was never about we can save labour. It was about a desire to farm better and how we could build technology that we could be better farmers with, and that's kind of the ethos behind the company.
From a Verdant Robotics perspective, it's kind of interesting because the company started doing apple blossom pollination. So something I didn't know that I learned going to the company is that you don't necessarily want every blossom on an apple tree pollinated. You only want a certain population populated, because that tree can only support so many fruit, and so they're looking for a certain size and a certain quality to go to market, and that's what they get paid for. So the technology actually was mounted vertically on the side of a UTV, and you drive through the orchard, and it would look for what they call the king blossom, which is the first blossom that comes out on the tree, and they would shoot pollen into that blossom. So that's where the very precise aiming technology came from. And then they'd go back a week later and they'd look at all the blossoms that were on the tree, and they'd look at morphological changes, and they could tell the one that had been pollinated versus the ones that were new. And the ones that were new, then they'd go through and they'd shoot a terminator compound to essentially thin the blossoms back. And so that looked like a good market, but then to develop that, you have to do some testing in North America, and then you have a South American market as well. And 2 turns to do development isn't very fast in a year for a startup company. And then on top of that, COVID hit right in the middle of their development. So the South American development season went away. So fortunately, some others in the West Coast industries had been paying attention to what Verdant was doing. And Bolthouse Farms, which is the #1 carrot producer in the country, came to them and said, hey, do you think you could do weed control with this thing? And so they looked at the system, and it wasn't very much to go from a vertical arrangement to a horizontal arrangement, and that's how Verdant kind of got into the weed control game. But as we've continued to develop and use machine learning and this targeting system, being able to do a lot of things other than just weeding, being able to do thinning in vegetable crops, which is a thing, and be able to apply other crop protectant products directly onto the plant, as well as identify particular parts of the plant and trying to understand what we could do there as far as maybe changing the way the plant grows to help increase yield, kind of like what we did in apples, is a reality in our row crops as well. So those are some of the things that we've kind of moved into, partly by stumbling upon them and partly by intention, but pretty exciting stuff.
Yeah, so one of the very interesting things I think when it comes to robotics in agriculture is that you seem to be able to find really good people that do robotics. You seem to find really good people that can do data science. You seem to find really good people that understand ag. But putting all 3 of those things together on a platform seems to be really, really difficult. And companies like yourselves seem to have been able to execute on that. So any lessons learned on how in the world do you bring together maybe 3 different types of people that don't normally get along or know how to work together to be able to build an ag platform that has robotics and computer vision on it?
Yeah, maybe I'll talk to that a little bit first, Andrew. Spent a lot of my career getting people who didn't like working together to work together. My previous part of my career, I was trying to get Americans and German engineers to work together, which was always kind of challenging. But I think the biggest thing is giving everybody the perspective that they need of the other areas that you need to bring together, right? So if you have somebody that's purely engineering mindset and, hey, I can use the engineering to overcome anything, I can use engineering to overcome biology, actually teaching them the importance of the particulars of the biology and why that matters, and helping them start to bridge that gap. You don't have to explain all of it to them, right? But you have to help them understand where touch points are between these functions and how those things work together. So if you can help to build that larger 30,000 foot view, then that allows them to start drilling down within their area, but consider, the other things like why ear orientation, matters to a corn harvester, for instance. So yeah, that's been my experience, Brad.
Yeah, and there's probably 2 things that come to mind. I was just talking to Chad about this just before, but we've both got a background in agronomy, and Swarm Farm has been an agronomically led company. Myself as an agronomist and then a farmer. I'm not an engineer. I'm a farmer myself, and actually understanding what happens on farm and being immersed in that has probably been the key to bringing technology and engineering and data science and all these things together in a practical way. And I've always said to our team, one of our secrets to success has been the fact we've been based on farms. So from day one, all of our engineering, all of our development has been immersed on a 10,000 acre cropping farm. And so it's the stuff that breaks at 3 o'clock on a Tuesday morning that the engineering team are there, and our engineering team start at 6. Well, they used to start at 6 o'clock. They're getting a bit sleepy now, but they start at 7. But they're there at 7 o'clock the next morning to see what went wrong. And that's what hardens the technology and makes them understand what really needs to happen for the edge cases and the tricky things in robotics. And so without that, it's really hard for those engineers and guys that are doing mathematics to understand practical relevance of what they're doing and how it needs to work for a farmer. So that's the second thing for us, and that's been really helpful for us for sure.
Yeah, that's fantastic. I think we here at Beck's have noticed that both of your companies have built incredible teams with great people that understand farming. It's interesting, Andrew, that you say that you're an agronomist and yet you own a very successful robotics company. So congratulations on bridging that gap there. But why don't you talk for a little bit about the strategy? Because what I think is interesting is when we talk about autonomy and self-driving things or automating things at the farm gate, your two companies have adopted very different strategies. So, Andrew, I would say your company is autonomous first, right? And, when I look, Chad, at Verdant, it's an autonomy last sort of strategy. So why don't you talk just for a little bit about, I'm not saying that there's a winner and a loser here, but the pros and cons of adapting maybe those different strategies of being autonomy first versus autonomy last.
Yeah, I guess for us, I wanted to see a big picture in farming when we started the company. It was about putting new tools and new techniques in the hands of farmers so we can be better farmers. And, I believe that it can't be one thing. It needs to be multiple people thinking from an agronomic point of view, how do I grow corn better in the Midwest? And someone else needs to think how to grow corn better in Europe. And someone else needs to think how to grow it better in Asia. Different soils, different climates. It's even different markets for those things. And so I believe we need a diversity and lots of thinking and lots of different companies bringing robotics to market and rethinking that agronomy, because we're dealing with Mother Nature here. We need multiple technologies to come together out of robotics for it truly to be successful. And so our decision strategically was to work with autonomy only and then help bring these robotics to market, because so much of this advanced robotic technology needs to move really slowly and really accurate. So we figured if we can solve that, then we can help companies like Verdant and others get their piece in the field to make that difference for farmers. So our robots are useless on their own. Yeah. We need Verdant and the other companies working with us. So we see it as a partnership where farmers win, where our partners win that are developing technology that goes on board, and we win as a company because we all win together, and that's kind of been our philosophy. So we don't ever build anything to go on board our robots. In fact, they're useless without a partner technology on board, and that's kind of our business model.
From the Verdant perspective, I think we see that there is a lot of effort in full automation, vehicle automation already. So we didn't want to be another player in that space. There's already people that have the ag knowledge and understand the conditions and everything, like Swarm Farm. So we weren't going to get in there and try to compete there. Part of it too is our team is full of folks that worked at NASA and landed the rover on Mars and drove it around, guys that helped develop the F-22 and F-35. Our founder Gabe came from a background at Georgia Tech and Stanford working in robotics. So for them, the automation is kind of like, well, we've been there and we've done that. We haven't done it in ag, but that we don't really see that as the challenge. The challenge is how we bring scale level automation of jobs into the marketplace. So the perspective was more, not the full automation. We'll work within whatever the industry develops as full automation. It was more of those individual jobs, especially jobs that require manual labor. How can we begin to automate those things?
So what I'm hearing is that you guys are ready here at Technology Days to announce a partnership then between Swarm Farm and Verdant. Is that what I'm hearing?
I think I might get fired if I state something like that, Brad.
Hey, wouldn't be the first time, won't be the last. So one of the unique things, as we talked about, is, and you touched on it briefly, Chad, but like the cycles at which we learn and innovate can be difficult for us that work here in the Midwest and the U.S. with row crops because we get one season per year. And so the ability to learn and get better, our innovation cycles are not maybe as fast as some other parts of the world, and that. So you guys have kind of hinted around with it, but like, how do you learn faster, and how do you get more of these innovation cycles? How do you learn faster than your competition, and how do you deal with these constraints that some of us have these blinders on that, I can only test one time per year, and how do I get better faster? How have you guys addressed that whether it's people or geography, or like, how have you overcome that?
Yeah, there are a lot more digital tools that we can use today. Actually, I was just speaking kind of about this to the American Society of Agronomy a few weeks ago. We had an online seminar, and I came out of the engineering world, so I'm an engineer and an agronomist, right, Brad? So
you're very confused about what
yeah,
you're doing
exactly.
every day.
I'm always my two brains are always fighting each other, but when I was an engineer earlier in my career, it was all about taking equipment around, trying to test it in different conditions, chase things around. And one of the things I was actually able to do was to bring the agronomic aspect into it. So this idea that if you understand the biology enough, you can actually create the conditions that you want in more of a controlled situation. So for instance, we ran into a hybrid up in Minnesota that created really high spreading loads on the stalk rolls, and were creating some failures. And I told my team, I said, we don't have to go to Minnesota every year to test that. We can plant that here in central Illinois and get the same conditions, and we can, plant 5 acres, and that's all we really need, right? So we kind of propped up a little bit of a test situation with a farmer on 80 acres where we had 5 or 6 particular crop conditions that we were looking for that we were able to create on a small acre basis. So there's some things there that if you understand the biology a little bit better, it can lead the engineering effort. But then on the digital side, everything that we do to create equipment is around, doing finite element analysis and recreating things on test stands and things like that. We're actually getting to the point where we can start doing that with crops as well. So, developing what we call digital twins for the agronomy side of it is going to be, we're just beginning in that area, but that's how we're going to get away from being so constricted by seasons and the weather and things like that, and be able to move things, not just into the lab and the greenhouse, but really into the virtual world as well.
Luckily in Australia, it only rains about one week a year, so and it doesn't snow, so it does rain more than that. But we crop all year round, so we farm in winter, we farm in summer, we farm in spring, we farm in autumn, and so we're kind of blessed that we can kind of run continuous running with our robots. And early on, the early customers we worked with, we took our product to market really early and made sure we chose farmers, and every farmer we bought on early would sit down and say, hey, these things aren't perfect. You need to understand that, particularly in these early days, there's going to be times these things break down and we're not going to know how to fix it because it's going to be something new. And so we made sure that every farmer we onboarded in the early days kind of understood that. And then we just ran those machines into the ground, and we kind of got our experience that way. And so we're kind of lucky, a bit of a natural advantage for us, because we don't stop in winter. We just keep going. And, we've got a lot of farmers who'll put 3,000 hours a year on their robots. And so, no one does that with a tractor. But we're able to do that, and that really pushed our early learnings in the field with commercial customers that kind of help solve those edge cases. And they're the hardest ones to solve, right? It's those little edge cases that get you that no one thought of, and then you've got to solve them quick. So we're very lucky for that in the location we're in.
Yeah. So we're on the second day of Technology Days here. You guys, we drug you through 6 tours yesterday that you guys were able to do on our autonomous tour. What were some of the questions? Because when people see the technology for the first time, I mean, our minds tend to race and ask a bunch of questions, but briefly talk on like what is either the major question or the major objection that you've heard from folks here over the last day. And you guys have both done an extensive U.S. tour, so what's the number one thing people look at a Verdant machine, Chad, and what's the first question that you normally get that pops into their mind?
Well, the first impression is no questions, because they're pretty shocked at what the technology can do. It's literally delivering milliliters of liquid on the target, where we're normally used to just fogging a liquid across the field, right? So the first reaction is trying to get your mind around, is this real? and how is this going to work in my system? But then those questions start coming. So a lot of the questions around, well, how close can you get to the crop? How big can the crop be when we can use that? So very quickly, people are making the transition to, okay, I get this. This does work. I'm seeing it. I believe it. How is this going to work in my operation? So that's the biggest. That's probably the biggest question I get. Is very specific to a grower's operation. How do you think that this can work? Which is great, because that's the conversation that we want to get to. The biggest objection is all of our objections, the cost of things, right? So,
wait, your product costs money?
Nope, it sure doesn't. It costs blood, sweat, and tears.
It makes you money. That's what it does. It's a money maker.
Yeah.
But we're very early in our development process. We've only been selling this product for 7-8 months. So we're still going through price discovery. We're held captive by some of the technologies that we use, NVIDIA processors and things like that everybody else are fighting over as well. The cost of things that are going on with our trade wars and that. So we're subject to that as well. But we're hopeful that as technology continues to improve and that we learn more about how our technology works, we're going to be able to do things more efficiently on our machine, and we're going to be able to bring that cost down. So it's like anything else in the ag tech space. The price point is higher than where we'd like it, but customers, we're able to have an ROI conversation with customers and walk them through, okay, this is what it costs, but these are the values that we're bringing, and in dollars and cents, this is what you're going to see at the end of the year. So there is a customer base where it fits great right now, but for Midwest corn and soybean farmers, we're not quite there yet, but we're definitely working that direction.
I think from our side, it's probably similar in some ways, like a bit of disbelief that the technology exists and is available now and is commercially viable. And I guess we spend a lot of time talking about our experience back in Australia with the adoption of autonomy and how it's really heading mainstream in that Australian market. And it's a bit unique that we're able to do that. And we also get a lot of questions about, I guess, precision spraying. Once again, it's another technology that's mainstream in Australia. And in the US, See and Spray's reached here now, and it's a lot of hype around it. Yep. And a lot of people still, in a discovery stage, I think, even with just, simple spot spray technology, not so much the advanced kind of technology that Verdant has that points and shoots. But like in the Australian market, spot spray technology like See and Spray, 70% of farmers there have it now and are already using it. So it's mainstream. You don't have to have that explanation about how it fits into their agronomy or how it works, because a lot of our robots go out with that technology on board. And so I find that quite interesting, and taking people on a journey about how that changes the agronomy around how you farm when you start deploying that technology on your farm. So that's probably the bit we get the most curiosity out of, I think.
Yeah, so both of your companies, you are commercial right now in the sense that you have a product that you're selling. This is not, a science experiment. What are there certain qualities that you look at where you're like, here are the qualities of a great early adopter customer that we would like to have? So, Chad, you mentioned a little bit about everybody's trying to find that product market fit of how's this going to work on my farm after they get through the objection of, is this actually real? But like, are there certain qualities that you're like, oh, here is a great early adopter customer, and here are farmers and growers that I would love to connect with and try to get on those farms first? I mean, everybody knows, Chad, the Illinois farmers are, the best. So
well, we have that, rich, deep, black, rain-fed
right.
soil, and it's just super easy farming over there, right? So we're just all flush with cash,
it's
right?
so easy in Illinois. But like, are there certain qualities that you guys have noticed that, hey, these are the things that are going to get us great customers as we start to turn commercial?
Yeah, I can jump into that. I'll give you a little time to think about that. Because, I'm experiencing it with Verdant. I experienced it in my previous career experiences as well, bringing technology to the market. And so you have to find customers initially that are able to get their head around how the technology works and start thinking about how it fits in their operation. Like, you have to find people that you can see the gears turning right off the bat, right off the initial conversation. But then people that have a deep understanding of their operation and the things that they're doing, the small changes that they're already making in their operation, that make it more sustainable, more successful. And when I say sustainable, not just environmentally sustainable, but economically sustainable as well, right? So what I found is the people that understand their businesses the best also tend to understand the technology the best and how it fits well. So when you have those deep business conversations with people, you know that you've got a customer that is probably going to be a good partner. You also, the other big quality is grace, understanding, flexibility, right? Because as you're developing those technologies, you don't have everything 100% baked. You're still learning. So you want somebody that also has that exploration kind of mentality, right? And has the understanding and the flexibility that, hey, this isn't baked yet, and I want to be kind of a journey partner along with you. I still understand that I'm the customer, but I'm willing to give you some grace because I want to see this technology evolve and develop and eventually land in the market. So those are the two big qualities that we always look for.
Yeah, and I think just thinking about another perspective on this, I see a lot of ag tech companies go to find a corporate farm or a really large one that's got a really big checkbook and think that's the customer to target. Our experience has probably been the opposite. So find the smart family operators that are switched on, and as you said, know their numbers, know their agronomy. Make sure that there's a real ROI for them. So there's people that want the dream, but there's not going to be an ROI for them. It just doesn't quite fit. Make sure we truly understand what success looks like and identify that the ROI can be there for them. And then we like to work with them in a partnership, particularly in our early days when we're getting our first robots to market. And we've had the experience with, and it's not always the experience, but we've had the experience with really large operators in terms of corporate type farming where they want the dream, but they don't necessarily have the people in place to make that technology work and see it through. There's a bit of a disconnect. So we tend to go for family farmers every time, particularly on release of new technology, because they work so deeply with you. They're so invested in, and they've got the patience and they've got the tenacity, I think, to see it through. And we've just got to make sure that ROI is there for them as well, because no one wins. If the ROI is not going to be there for them, you're not going to win. So that's something else we definitely look for as well.
Yeah, well, good. Well, as we start to wrap up here, guys, what do you think the next 6 months looks like? Are there any new products, new features? What excites you here with both of your companies as we look out in the next six to 12 months? I mean, not that we're asking for a major product announcement, but what do you guys have up your sleeve?
Oh, it's easy. When we'll put the Verdant on the back and we'll take the world over.
So we are continuing to look at new crops, new geographies, what machine forms we need to fit those. We've got some ideas of things that we might want to bring to the market. So our big show, because we're based on the West Coast and fit that vegetable crop market, is World Ag Expo in February. So I'll just say if we've got anything coming along, look for something in February.
Okay.
For us, autonomous docking system, so the robots can refill themselves. It's that last tether. I mean, large farm machinery has big capacity, small farming machinery has small capacity. But once you've got autonomous dock and refilling on there, that autofill system, little robots can go all day, all night, and all of a sudden we've got the same productivity as big machines. That is a big one. We've been working on that now for 5 years, and we've finally just got first customers to market. So you'll see a lot of that come from Swarm Farm in the next 6 months.
Yeah, that's amazing. Well, guys, thank you very much for all that you've done. Thank you guys for both your companies for innovating in this space. We're super excited about the future of what you guys are doing. Thank you for your time today. This is going to wrap up today's Corn Conversation. Thank you very much.
Thank you.
Terrific. Thank you very much.